Okay.
So
we'll start.
Okay.
Please.
Good evening, everyone. Today we have with us an eminent person, Dr. Suresh Nair, to speak about one of the most important branches in engineering, especially in the COVID days, the biomedical engineering. Let me introduce Dr. Suresh Nair. Dr. Suresh Nair is an alumnus of Department of Electrical Engineering, IIT Bombay, and has spent his initial career at TIFR and subsequently at Zamir R&D Lab of Ministry of Information Technology, Government of India. Later, he was with NEST, as a global chief technology officer heading the technology strategies. Under his leadership, designed and developed many novel products in healthcare, communication domains, and many are finding excellent market acceptance globally. Dr. Suresh Nair is presently the Chief Technology Advisor to Foundation for Innovation and Social Entrepreneurship, an initiative of Tata Trust, and also founder of two companies, Design Alpha and Biophoton Technologies. Dr. Suresh Nair has more than 120 publications, 18 patents, co-authored 3 books, and more than 200 technical reports to his credit. He has been conferred with many awards, including IEEE Outstanding Researcher Award, DST Lockheed Martin Award 2014 for the top innovation as ranked number 1 in India, BV Baliga Award, IET OE Award, to name a few. He is chairman of many Government of India committees on R&D, member in various government steering committees like MET, DSIR, etc. He is also in the project management group of Maker Village, member in Nidhi Prayas, DST Healthcare Hub, etc. He is a governing council member on additive manufacturing set up by MET, Government of India. He is fellow IETE, fellow OSI, senior member IEEE. Dr. Suresh is currently chair-elect IEEE India Council and is an active promoter of Academic Industry Association, and his passion is to mentor youngsters as entrepreneurs. I welcome you, sir, to the session. Over to you.
Good afternoon, and first of all, thanks to Findo for nice words and Kasim sir for having this program. So I'll be very brief here. This is mainly on biomedical engineering. കുറച്ച് മലയാളം കൂടെ പറയാൻ ഇടയ്ക്ക് സാധാരണ നമുക്ക് +2 കഴിഞ്ഞാൽ ഒന്നി ഡോക്ടർ ആകണം അല്ലെങ്കിൽ എഞ്ചിനീയർ ആകണം. ഇപ്പൊ രണ്ടിനും അതാത് പ്രത്യേകതകളുണ്ട്. So if you want to, normally people stay away from engineering കാരണം എന്ന് പറഞ്ഞാൽ ഒരുപാട് മാത്സും കാൽക്കുലേഷൻസും അതൊക്കെ ഒരുപാട് ഉണ്ടെന്ന് പറഞ്ഞിട്ടാണ്. പക്ഷെ അങ്ങനെയൊന്നും അല്ല. ലൈക്ക് ഇൻ എഞ്ചിനീയറിംഗ്, ഇൻ എനി എഞ്ചിനീയറിംഗ് യു ഹാവ് ടു ഗോ ത്രൂ സം ലിറ്റിൽ ബിറ്റ് മാത്സ്, ബട്ട് when you go for engineering studies like BTech and all, maths എന്ന് പറയുന്നത് that is actually applied in some cases, in some application, real life application. അത് ചെയ്ത് വരുമ്പോഴാണ്, ഫോർ എക്സാമ്പിൾ ഇന്റഗ്രേഷൻ എന്ന് പറയുന്നത് നമ്മൾ സാധാരണ സിമ്പിളൊക്കെ ആയിട്ട് എഴുതുമ്പോൾ അത് വേറെ എന്തോ പോലെയൊക്കെ തോന്നും. ബട്ട് ഇഫ് യു അപ്ലൈ ദാറ്റ് ഇന്റഗ്രേഷൻ ഇൻ റിയൽ ലൈഫ് വേൾഡ്, ഫോർ എക്സാമ്പിൾ ഒരു ഡാർക്ക് റൂമാണ്. ഡാർക്ക് റൂമിൽ നിങ്ങൾ ഒരു ക്ലോക്ക് വെച്ചിട്ട് ആദ്യം ലൈറ്റ് ഓഫ് ചെയ്ത് നോക്കുമ്പോൾ ക്ലോക്ക് കാണത്തില്ല. കുറച്ച് സമയം ആ ക്ലോക്കിനെ തന്നെ നമ്മൾ നോക്കി നിൽക്കുകയാണെങ്കിൽ, ഡാർക്ക് റൂമാണ്, ലൈറ്റ് ഓഫ് ചെയ്തു, ആ ക്ലോക്കിന് നോക്കി നിൽക്കുകയാണെങ്കിൽ നിങ്ങൾക്ക് പതുക്കെ ടൈം അറിയാൻ പറ്റും. Basically an integration is happening in your eyes. അപ്പോൾ അത് വരുമ്പോഴുണ്ട് സിഗ്നൽ, ഈ നോയ്സിന്റെ താഴെയുള്ള സിഗ്നൽ എല്ലാം മേളിൽ കയറി വരും. അങ്ങനെയാണ് നമ്മൾ കാണാൻ പറ്റുന്നത്. അപ്പൊ ഇതൊക്കെയാണ് ഓരോരോ ആപ്ലിക്കേഷൻ. നമ്മൾ പഠിക്കുന്ന എല്ലാ മാത്സിനും, എല്ലാ ഇന്റഗ്രേഷൻ ആയാലും ശരി, ഡിഫറൻസിയേഷൻ ആയാലും ശരി, വാട്ട് എവർ യു ലേൺ, there is an application for that. ആ ആപ്ലിക്കേഷൻ മനസ്സിലാകുമ്പോൾ then you love maths and all these techniques. So today I'm going to talk about biomedical engineering. Let us so this is basically this deals with it's a set of engineering principle and methods that helps in solving medical and biological problems. But doctors in the kuda oru step design cheyan parnja avarku pattathilla. Okay, പക്ഷെ നമ്മുടെ എഞ്ചിനീയേഴ്സ് ആയിരുന്നിട്ട് നമ്മളത് അങ്ങനെ ഒരു ഡിവൈസ്, ഒരു ഗാഡ്ജറ്റ് ഡിസൈൻ ചെയ്ത് ഡോക്ടേഴ്സിന് കൊടുക്കുമ്പോൾ അത് അവർക്ക് യൂസ് ചെയ്യാൻ പറ്റുന്നുണ്ട്. ഓക്കെ, സോ ദിസ് ഈസ് ഹൗ ഇറ്റ് വർക്ക്സ്, ബോത്ത് മെഡിക്കൽ ആസ് വെൽ ആസ് the engineering side has to go hand in hand. So now this branch of engineering is very close to humanity and society as a whole. This is very, very important. So whatever you do a study, for example, any branch in engineering or medicine or whatever you do, your fee, or your study expenses mainly are borne by government. Government means it is by society. അപ്പൊ സൊസൈറ്റിയാണ് നമ്മൾ സപ്പോർട്ട് ചെയ്ത് നമുക്ക് ബിടെക്കും എംടെക്കും PhDയും എല്ലാം വാങ്ങി തരുന്നത്. ഓക്കെ, അതുകൊണ്ട് അറ്റ് സം പോയിന്റ് ഓഫ് ടൈം യു ഹാവ് ടു ഗിവ് ബാക്ക് ടു ദ സൊസൈറ്റി. അപ്പൊ സൊസൈറ്റി നിങ്ങൾ ഇത്രത്തോളം വലിയ ഇതാക്കി, അപ്പൊ നിങ്ങളുടെ യു ഹാവ് ടു ഓൾസോ ഗിവ് ബാക്ക് ടു ദ സൊസൈറ്റി. ഈ ബയോമെഡിക്കൽ എഞ്ചിനീയറിംഗ് എന്ന് പറയുന്നത് വളരെ ക്ലോസ് ടു ഹ്യൂമാനിറ്റി ആണ്. ബിക്കോസ് ഐ വിൽ എക്സ്പ്ലെയിൻ ദാറ്റ്. എല്ലാ ഗാഡ്ജറ്റ്സും നമ്മളാണ് ഡിസൈൻ ചെയ്യുന്നത്. So that is one thing. Of course, teachers, but teaching profession eduthalum, that is also very close to society because they are building a lot of the resource. Nammade ella build cheyunna teachers aanu. Angane ella idinu undengilum biomedical engineering is very much close to society, humanity and society as a whole. So idu we have to understand. If you look more into biomedical engineering, this is more on electronics and instrumentation mainly, with good knowledge on medical and biological aspects. ഇതിന്റെ ഡിഫറൻസ് എന്ന് പറഞ്ഞാൽ ഇപ്പൊ ഇലക്ട്രോണിക്സ് എഞ്ചിനീയറിലൂടെ ഇന്നത് വേണം, ഇങ്ങനെയുള്ള ഒരു ഡിവൈസ് വേണം എന്ന് പറഞ്ഞാൽ അവർ ചെയ്യും. പക്ഷെ എങ്ങനെയുള്ള ഡിവൈസ് ആണ് വേണം എന്നുള്ളത് പറയേണ്ടത് ഇപ്പൊ മെഡിക്കൽ ഏരിയയിലാണെങ്കിൽ, ഇപ്പൊ ഫോർ എക്സാമ്പിൾ നമ്മുടെ ഹാർട്ടിനെ നമ്മൾ മോണിറ്റർ ചെയ്യാം. അപ്പൊ എങ്ങനെയുള്ള സിഗ്നൽ ആണ് ഇവിടുന്ന് വരുന്നു എന്നുള്ള ആ ഇൻഫർമേഷൻ നമ്മൾ കൊടുത്താൽ മാത്രമേ ഇലക്ട്രോണിക്സ് എഞ്ചിനീയർ ചെയ്യാൻ പറ്റൂ. ഇൻസ്ട്രുമെന്റേഷൻ ആൾക്കാർ ആ ഇൻസ്ട്രുമെന്റ് കൊണ്ടുവരാൻ പറ്റത്തുള്ളൂ. അപ്പൊ ഈ ബയോളജിക്കൽ ആസ്പെക്ട്സ്, എല്ലാ സിഗ്നൽസും ബ്രെയിൻ വേവ് എങ്ങനെയാണ് വരുന്നത്, അല്ലെങ്കിൽ ഇങ്ങനെ വന്നാൽ എന്താണ് ഇതിന്റെ പ്രശ്നം, ഇങ്ങനെയുള്ള എല്ലാ കാര്യങ്ങളും നമുക്ക് ഈ ബയോമെഡിക്കൽ എഞ്ചിനീയറിംഗിൽ ചെയ്യാൻ പറ്റും. ഇനി ഏതെങ്കിലും ഒരു ഹോസ്പിറ്റലിൽ നിങ്ങൾ പോവുകയാണെങ്കിൽ ദിസ് ഈസ് ഹൗ ഇറ്റ് ലുക്സ് ലൈക്ക്. ഹോസ്പിറ്റലിൽ ഒരു ഡോക്ടർ കാണും, ബാക്കി എല്ലാം ഇക്വിപ്മെന്റ്സ് ആണ്. അവിടെ വെന്റിലേറ്റർ ഉണ്ട്, അവിടെ ബാക്കിയുള്ള കാര്യങ്ങളെല്ലാം ഉണ്ട്. ECG മെഷീൻ ഉണ്ട്, CT സ്കാൻ ഉണ്ട്, MRI സ്കാൻ ഉണ്ട്. നിങ്ങൾ ഏതെങ്കിലും ഒരു ഹോസ്പിറ്റലിൽ അകത്ത് പോയി ഇതൊക്കെ കാണാം. ഇതൊക്കെ ഇക്വിപ്മെന്റ്സ് ആണ്. ഇതൊക്കെ ഡിസൈൻ ചെയ്തത് വിത്ത് ദി ഹെൽപ്പ് ഓഫ് ബയോമെഡിക്കൽ എഞ്ചിനീയേഴ്സ്. ഇത് ഓപ്പറേറ്റ് ചെയ്യുന്ന ഒരുപാട് സിസ്റ്റംസ് ഓപ്പറേറ്റ് ചെയ്യുന്നത് ബയോമെഡിക്കൽ എഞ്ചിനീയേഴ്സ് ആണ്. അവരെയാണ് ഈ ഹോസ്പിറ്റൽസിലൊക്കെ എടുക്കുന്നത്. ഇതിന്റെ മെയിൻ്റനൻസും ഇതിന്റെ സർവീസിങ്ങും ഡോക്ടേഴ്സിന് ഹെൽപ്പ് ചെയ്യാൻ വേണ്ടി ഇവരാണ് പോയി പറഞ്ഞു കൊടുക്കുന്നത് ഡോക്ടേഴ്സിന്. ദിസ് ഈസ് ഹൗ ദിസ് ഹാസ് ടു ബി യൂസ്ഡ്. അപ്പൊ ഇത്രയും വളരെ ഇമ്പോർട്ടന്റ് ആസ്പെക്ട് ആണ് നമ്മുടെ ഈ ബയോമെഡിക്കൽ എഞ്ചിനീയറിംഗ് എന്ന് പറയുന്നത്. ദാറ്റ്സ് വാട്ട് ഐ വാണ്ട് ടു എംഫസൈസ് ഓൺ ദാറ്റ്. പിന്നെ ഡോക്ടർ ഫിൻഡോ പറഞ്ഞതുപോലെ COVID-19 പാൻഡമിക് വന്നപ്പോഴുള്ള കാര്യങ്ങൾ നിങ്ങൾക്ക് എല്ലാം അറിയാമായിരിക്കും. എന്ത് പറ്റി? എല്ലാവരും ഇവിടെ ടെസ്റ്റ് ചെയ്യാൻ പോകാൻ തുടങ്ങി. ലൈക്ക് യു ഹാവ് ടു ഡു ദ ടെസ്റ്റിംഗ്. വേരിയസ് ടൈപ്പ് ഓഫ് ടെസ്റ്റിംഗ് ആർ ദെയർ. ഫോർ എക്സാമ്പിൾ ഐ ആം ഷോയിങ് ആന്റിജൻ ടെസ്റ്റ് ഇക്വിപ്മെന്റ്. അപ്പൊ ഈ ഇക്വിപ്മെന്റ് ഡിസൈൻ ചെയ്ത് വച്ചാൽ മാത്രമേ നമുക്ക് ഇതിന്റെ ടെസ്റ്റിന്റെ റിസൾട്ട് കിട്ടൂ. So what doctors or clinicians or technicians ചെയ്യുന്നത്, അവർ വെറും ഒരു സ്വാബ് എടുത്തിട്ട് ആ ലിക്വിഡിന്റെ ആ പാർട്ട് ഇതിനകത്ത് കൊണ്ടുവച്ചിട്ട് പിന്നെയാണ് അത് എക്സ്പെരിമെന്റ് ചെയ്യുന്നത്. ഫോർ എക്സാമ്പിൾ അതിനെ കുറെ ഷൈൻ ചെയ്യും, അല്ലെങ്കിൽ കുറെ സമയത്തേക്ക് വെച്ചിട്ട് എന്താണ് വരുന്നത് അതിന്റെ റിസൾട്ട്സ്. You can add so many other things, chemicals, and then find out what happens after some time. So all those equipments are designed by the biomedical engineers. So ഇത് നിങ്ങൾക്ക് അറിയാമായിരിക്കുമല്ലോ, ഇപ്പൊ എന്നും പ്രശ്നമാണ് ഇവിടെ എത്ര ടെസ്റ്റ് ഒരു ദിവസം ചെയ്യാൻ പറ്റും എന്നുള്ളത്, അതിന്റെ അവൈലബിലിറ്റി ഇല്ല. സോ ഈ COVID-19 has shown that there is a huge requirement for biomedical engineers. Other ventilators എന്നും കാണാം, ഇന്നത്തെ പത്രത്തിലുണ്ട്. ഇന്നത്തെ ഹിന്ദു പേപ്പർ ഇഫ് യു സീ, they are saying like 3 startups have come up with ventilators here. I was also involved in developing some ventilator which is being used in Tata Hospital. The other ventilator, we were not having enough ventilators because COVID there is some specific requirements. സാധാരണ വെന്റിലേറ്റർ യൂസ് ചെയ്യാൻ പാടില്ല because lot of requirements are there. All those requirements, even though doctor will say, but it is given to a biomedical engineer who interprets that and give to a designer. ഇപ്പം ബയോമെഡിക്കൽ എഞ്ചിനീയർ ഇതെല്ലാം ഡിസൈൻ ചെയ്യണമെന്നില്ല. ഇതിന്റെ ഇലക്ട്രോണിക് പാർട്ട് ഇലക്ട്രോണിക്സ് എഞ്ചിനീയർ ചെയ്യും, അതിന്റെ സോഫ്റ്റ്വെയർ എഴുതുന്ന സോഫ്റ്റ്വെയർ ആൾക്കാർ ചെയ്യും, കമ്പ്യൂട്ടർ സയന്റിസ്റ്റ്, then മെക്കാനിക്കൽ ഡിസൈൻ ചെയ്യും, ഇൻഡസ്ട്രിയൽ ഡിസൈൻ ചെയ്യും. എന്നാലും ഇതിന്റെ ആ ഇന്റർഫേസ് വരുന്നത് ബയോമെഡിക്കൽ എഞ്ചിനീയേഴ്സിനാണ്. ബയോമെഡിക്കൽ എഞ്ചിനീയേഴ്സ് ഓൺലി ക്യാൻ ടെൽ ലൈക്ക് അതിൽ എത്രയാണ് പ്രഷർ കൊടുക്കാനുള്ളത്, എങ്ങനെ വരണം, ഏത് രീതിയിലാണ് ഇത് കൊടുക്കാനുള്ളത്. സോ ഇതെല്ലാം വരുന്നത്. Then now പൾസ് ഓക്സിമീറ്റർ, ഇപ്പൊ പറയുന്ന എല്ലാവരുടെ വീട്ടിലും പൾസ് ഓക്സിമീറ്റർ വേണം എന്ന് പറയും. ദിസ് ഈസ് വെരി വെരി ഇമ്പോർട്ടന്റ്. because if your SpO2, oxygen saturation level, is 99, then that is good. Actually, this is being continuously monitored on the COVID patients. Idum adutha idana. Idella mikavarum ella nammal import cheyana. Even though a few companies have started building like ventilators, ivide oru Scanray nu parnondu company cheyyunnundu, pinne G cheyyunnundu, Bell ippam cheyyunnundu, defense enna cheyidittu Bellinu kodutittundu to produce volume manufacturing like number of ventilators. So even pulse oximeter, there are a few companies that have come up with this one. So idella idinte ippam for example or electronics engineer or mechanical alkarku ee pulse oximeter ingane കാണുന്ന ഒരു ഡിവൈസ് ചെയ്യാൻ പറ്റും. പക്ഷെ അതിന്റെ അകത്ത് എങ്ങനെയാണ് സിഗ്നൽ വരുന്നത്, എന്ത് സിഗ്നലാണ് അനലൈസ് ചെയ്യാനുള്ള, എങ്ങനെയാണ് അനലൈസ് ചെയ്യുന്നത്, all these things will be shown by the biomedical engineer. Okay, now this is an MRI actually. So I am also working with one of the MRI thing which is funded by Tata Trust, where the cost of MRI is brought down drastically through some innovation. It is not at out in the market. It is still, we are doing testing at Satya Sai Baba hospital in Bangalore. Okay, leaving that, so ഇതിലൊരു ഇമ്പോർട്ടൻസ് പറയാനുള്ള, നമ്മൾ പഠിക്കുമ്പോൾ ഈ 4 years പഠിക്കുമ്പോൾ ഈ ബേസിക്സ് മിക്കവാറും എല്ലാ ഡിസിപ്ലിനും കോമൺ ആണ്. സിവിൽ ആയാലും ശരി, മെക്കാനിക്കൽ ആയാലും ശരി, ഇലക്ട്രിക്കൽ, ഇലക്ട്രോണിക്സ് എന്തെടുത്താലും ശരി, എല്ലാം കോമൺ ആണ്. Those are all the basic things. Now in biomedical thing we have to be a little bit more careful. For example, assume നിങ്ങളാണ് ഇത് ഡിസൈൻ ചെയ്യുന്നതെന്ന് വെക്കും, ഈ MRI. നമുക്കൊരു, നമ്മൾ ശരിക്കും പഠിക്കേണ്ട സമയത്ത് ശരിക്കും പഠിക്കാതെ ഒരു ചെറിയ മിസ്റ്റേക്ക് ഇതിലുണ്ട്, ഒരു ബഗ് വരുത്തിയെന്ന് വെക്കും. അപ്പം നമ്മളൊരു സാധനം ഡിസൈൻ ചെയ്തു, അതിലൊരു ബഗ് ഉണ്ട്, ഒരു മിസ്റ്റേക്ക് ഉണ്ട്. അപ്പം അടുത്ത് നമ്മുടോ അല്ലെങ്കിൽ our relatives may go through the MRI scanning and you see that there is, even though I don't have any problem, but when you are scanned through this MRI, it shows like there is a tumor in my whatever my brain, for example, even though it is not there. It endukondu vannu because you have not done the design properly. So ee 4 years padikkumbom whatever you are going to do, irrespective of the domain, you have to understand the basic principles. Ee 4 years padikkunnadinte extension maatramana whatever you go out, whatever you can do in MTech or PhD or anything, all those things are based on what you have learned through this initial basic principles. Basic principle പഠിക്കണം. അതുകൊണ്ടാണ് ഞാൻ പറയുന്നത്, I think you have to be very very careful, you have to be very much attentive. This is the time you can grab everything, basics, understanding, so that you can flourish in your career. This I wanted to make it very clear. Actually, this slide I always used to show to my designers. The first slide I show. So if you make a mistake in your design, you may be suffering, your relatives may be suffering later on. Okay, so it is very very much required that you have to do a very good design. Very good design എങ്ങനെയാണ് വരുന്നത്, നമ്മൾ നല്ലവണ്ണം ബിടെക് അതിന്റെ ബേസിക്സ് ഒക്കെ പഠിച്ചെങ്കിൽ മാത്രമേ ഇത് വരത്തുള്ളൂ. irrespective of biomedical engineering, electronics ആയാലും electrical ആയാലും, most of the common things are, most of the basics are all common. Physics remains same, maths remains same. Okay, now സ്റ്റാർട്ടപ്പ് ഓപ്പർച്യൂണിറ്റീസ്, അതാണ് അടുത്തൊരു. ഒരുപാട് കമ്പനീസ്, ബയോമെഡിക്കൽ എഞ്ചിനീയേഴ്സ് ഇവിടെ തന്നെ ഇഷ്ടം പോലെ കമ്പനീസ് ഉണ്ട്. ജി ഹെൽത്ത് കെയർ, ഞാനൊന്ന് ജസ്റ്റ് ഒന്ന് വായിക്കാം. ഡൗൺ സംവെയർ അതിന്റെ ലിസ്റ്റ് തന്നെ നോക്കുമ്പോൾ തന്നെ നിങ്ങൾക്കറിയാം. ജി ഹെൽത്ത് കെയർ, ഫിലിപ്സ്, സീമൻസ് ഹെൽത്തിനിയേഴ്സ്, സ്ട്രൈക്കർ, ഹിൽറോം പേഷ്യന്റ് ബെഡ് ഉണ്ടാക്കുന്നത്, ബോസ്റ്റൺ സയന്റിഫിക് ബ്രെയിൻ റിലേറ്റഡ് തിങ്, തോഷിബ CT സ്കാൻ അൾട്രാസൗണ്ട്, ഹിറ്റാച്ചി മെഡിക്കൽസ്, അക്യുറേ, സൈബർ നൈഫ് എന്ന് പറഞ്ഞാൽ നിങ്ങൾ കേട്ട് കാണും. പലയിടത്തും എനിക്ക് തോന്നുന്നു അമൃതയിലുണ്ടെന്ന് തോന്നുന്നു ഒരു എക്യുപ്മെന്റ്, സൈബർ നൈഫ്. ഇറ്റ് ഈസ് യൂസ് ഫോർ ബ്രെയിൻ ട്യൂമർ, ഈവൻ ക്യാൻസർ സർജറി. ആക്ച്വലി ഇറ്റ് ബേൺസ് ദ ട്യൂമർ. ഹോളോജിക് എന്ന് പറയുന്ന ഒരു കമ്പനിയുണ്ട് which is looking for a lot of people, which is for mammography, breast cancer detection. Trivitron, it's a Chennai-based company. Trixel, X-ray-based company from Israel, they are also looking for that. Scanray, ventilation. BPL Medicals, so many things they make it. Medtronics, earlier it was called Covidian, it is there. Samsung, ultrasound, അങ്ങനെയുള്ള കാര്യങ്ങൾ ഇങ്ങനെ ഇഷ്ടം പോലെ. വോക്സൽ ഗ്രിഡ് എന്ന് പറഞ്ഞ സ്റ്റാർട്ടപ്പ് ഉണ്ട്, MRI ചെയ്യുന്നത്. AI ഹൈവേ, ആർട്ടിഫിഷ്യൽ ഇന്റലിജൻസ് ഹൈവേ, അവർ വരുന്നത് ഒരു ആർട്ടിഫിഷ്യൽ ഇന്റലിജൻസ് ബേസ്ഡ് സ്റ്റെതസ്കോപ്പ്, പിന്നെ കാർട്ടോസെൻസ്, ഈ ബ്രെയിൻ സർജറി നടത്തുന്നതിന്റെ അതിനെ ഓട്ടോമേറ്റ് ചെയ്യാനുള്ളത്, ഇങ്ങനെ ഇഷ്ടം പോലെ അവസരങ്ങളുണ്ട്. Then startup opportunities, if you look at yesterday's Hindu paper, you can see my my quote is also referred there. ഇഷ്ടംപോലെ ഇപ്പൊ ഹെൽത്ത് കെയർ സ്റ്റാർട്ടപ്സ് ഇവിടെ കൊച്ചി തന്നെ ഇഷ്ടംപോലെ ഇൻക്രീസ് ചെയ്യുന്നുണ്ട്. Why I am mentioning the startup is like many of you after BTech or even during BTech, if you have a very good idea, you can start your own thing. That is the boom. Startups in the boom on നടക്കുന്നത്. I think this is also a very good idea. There is lot of opportunities. Government is funding like anything in healthcare. A few more new areas you might have already heard: artificial intelligence, internet of things. എന്ന് പറഞ്ഞാൽ ഇപ്പം സെൻസേഴ്സ് വെച്ചിട്ട് എല്ലാം നമുക്ക് കണ്ടിന്യൂസ് മോണിറ്റർ ചെയ്തുകൊണ്ടിരിക്കാൻ പറ്റും. ആർട്ടിഫിഷ്യൽ ഇന്റലിജൻസ് വെച്ചിട്ട് നമുക്ക് ഡിസീസസ് പ്രെഡിക്റ്റ് ചെയ്യാൻ പറ്റും, അതിന്റെ ട്രീറ്റ്മെന്റ് പ്രെഡിക്റ്റ് ചെയ്യാൻ പറ്റും. ഇതാണ് that is what is going on. Something called predictive analytics based on huge data available from previous experience. For example, ഒരു ഡോക്ടർ ഒരുപാട് പേഷ്യൻസിനെ കാണുന്നുണ്ട്. ഈ കാണുന്ന ഡേറ്റ എല്ലാം സേവ് ചെയ്ത് വെക്കുകയാണെങ്കിൽ പിന്നെ ഒരു പേഷ്യന്റ് വരുമ്പോൾ നമുക്ക് പെട്ടെന്ന് തന്നെ റെഫർ ചെയ്യാൻ പറ്റും. ആ ഡോക്ടർക്ക് പെട്ടെന്ന് പിടികിട്ടും ഈ ട്രീറ്റ്മെന്റ്, ഈ മെഡിസിൻ കൊടുത്താൽ പെട്ടെന്ന് ക്യൂർ ആവുന്നുണ്ട്. ആന്റിബയോട്ടിക്സ് എന്ന് പറഞ്ഞാൽ ഇഷ്ടം പോലെ കൊടുക്കാൻ പറ്റും. അപ്പൊ അതിന്റെ ഏതായിരിക്കും ഇതിന് കറക്റ്റ് ആയിട്ട് കൊടുക്കാന്നുള്ളത് അതിപ്പോ ഡോക്ടറാണ് ചെയ്യുന്നത്. അതാണ് ഈ experienced doctors always we give lot of value. Same thing ഈ ഡോക്ടറിന്റെ മൈൻഡിലുള്ളത് it can be put in a computer so that data can be put and you can get a best treatment there. And another thing is early detection is the cure. That is what is very much going on in biomedical engineering. ഏതെങ്കിലും ഡിസീസ്, ഫോർ എക്സാമ്പിൾ ഒരു ക്യാൻസർ, I will show one device later. For example, breast cancer. Breast cancer is ഇവിടുത്തെ ഇന്ത്യയിലെ തന്നെ ലേഡീസ് മോസ്റ്റ്ലി യൂണിവേഴ്സിറ്റി ലേഡീസ് ആർ the major one is breast cancer. Breast cancer can be easily cured if it is detected at very early stage. ഒരു നമ്മുടെ സാധാരണ അറിയത്തില്ല, പിന്നെ മൂന്നാമത്തെ നാലാമത്തെ സ്റ്റേജിലാണ് നമ്മൾ എല്ലായിടത്തും പോകുന്നത്. അപ്പൊ സർജറി ചെയ്യും, കീമോതെറാപ്പി ചെയ്യും, പിന്നെ അതിനെ റിട്രീവ് സേവ് പേഷ്യന്റിനെ സേവ് ചെയ്യാൻ പറ്റാതെ വരും. അപ്പം നമ്മളുടെ മൈൻഡിൽ ഏർലി ഡിറ്റക്ഷൻ, ഒരു ചെറിയ ട്യൂമറിന്റെ ഒരു സാധനം വരുമ്പോൾ തന്നെ നമുക്ക് ഡിറ്റക്ട് ചെയ്യാനുള്ള എന്തെങ്കിലും ഒരു ഐഡിയ ഉണ്ടെങ്കിൽ ഐ തിങ്ക് ദാറ്റ് വിൽ ബി വെരി മച്ച് യൂസ്ഫുൾ ടു ദ സൊസൈറ്റി. സോ ഇവിടെ റൈറ്റ് ഹാൻഡ് സൈഡിൽ കാണുന്നത് സം ഓഫ് ദ ഡിവൈസസ് വിച്ച് വി ഹാവ് ഡിസൈൻഡ്. ഡൗൺ വൺ ഈസ് സംതിങ് ടു ഡു വിത്ത് പാത്തജൻ ഡിറ്റക്ഷൻ. അപ്പൊ അതിൽ ഈ പാത്തജൻ സാമ്പിൾ വെക്കുമ്പോൾ തന്നെ യു ക്യാൻ സീ ഇറ്റ് ഓൺ ദി സ്ക്രീൻ വാട്ട് ഈസ് ഹാപ്പനിങ്. ടോപ്പിൽ കാണുന്ന ഒരു ഇറ്റ്സ് എ വെരി ന്യൂ ഐഡിയ. ജസ്റ്റ് ബ്രീഫ് വേ ഐ വിൽ ടെൽ. ലൈക്ക് ഇപ്പം നമ്മുടെ ഇപ്പം ഡോക്ടേഴ്സ് പ്രിസ്ക്രിപ്ഷൻ എഴുതുന്നുണ്ട്, അത് ഫാർമസി പോയി മെഡിസിൻ വാങ്ങണം, അവർ ഓരോരോ പാക്കറ്റ് ആയിട്ട് തരും. ഇതിനെ നമ്മൾ വീട്ടിൽ കൊണ്ടുപോയി പിന്നെ ഓരോ സമയവും കഴിക്കാനുള്ളത് നമ്മൾ എടുക്കണം. അപ്പൊ ഇത് ഓൾഡ് ഏജ് ആൾക്കാരൊക്കെ വരുമ്പോൾ ഇങ്ങനെ ഒരു മെഷീൻ ഒരു കമ്പനി പ്ലാൻ ചെയ്യാണ്. ഈ പ്രിസ്ക്രിപ്ഷൻ ഈ മെഷീനിൽ കൊടുത്താൽ ഈ മെഡിസിൻ ഓരോ സമയത്തും ചെയ്യേണ്ട, ഇപ്പം മോർണിംഗിൽ ഏതൊക്കെയാണ് വരുന്നത് അത് മാത്രം ഒരു പാക്കായിട്ട് അതിൽ ഒരു ലേബിൾ ഒടിച്ച് കൊടുക്കും, അതിന് വരും. അങ്ങനെ ഓരോ ദിവസത്തേക്കും ഓരോ ടൈമിനുള്ള medicine you can get it packaged. So this is very much useful in the later in the later days. As I said, the job opportunities, engineering, biomedical engineering എന്നുള്ളതിൽ നമുക്ക് ഡിസൈൻ ചെയ്യാൻ പറ്റും, ആ രീതിയിൽ പോവാം. Management, that is very much hospital management and even biomedical engineering management. Medical administration, lot of requirements are there in that. Sales, you can go in selling മെഡിക്കൽ എക്യുപ്മെന്റ്സ്, അതും നല്ലതാണ്. റെഗുലേറ്ററി പ്രാക്ടീസ്, ഇത് ഒരു വളരെ റെയർ ദിസ് തിങ് ആണ്. ഓപ്പർച്യൂണിറ്റി ലൈക്ക് ഒരു ഹെൽത്ത് കെയർ എക്യുപ്മെന്റ് ചെയ്യണമെങ്കിൽ അതിന് ഒരുപാട് സ്റ്റാൻഡേർഡ് ടു ബി ഫോളോ. നമ്മൾ ചെയ്യുന്ന ഒരു എക്യുപ്മെന്റ് യൂസ് ചെയ്ത് ഒരു പേഷ്യന്റ് ഡൈ ആകാൻ പാടില്ല. നമ്മൾ ഡെവലപ്പ് ചെയ്യുന്ന ഒരു പ്രോഡക്റ്റ് കൊണ്ടുവന്ന ഒരു പേഷ്യന്റ് മിസ് ഡയഗ്നോസിസ് വരാൻ പാടില്ല. സോ അതിലേക്ക് വേണ്ടി ഒരുപാട് റെഗുലേറ്ററി പ്രാക്ടീസസ് ഉണ്ട്. ഫോർ എക്സാമ്പിൾ, ഒരു എന്തെങ്കിലും ഒരു എക്യുപ്മെന്റ് നമ്മളിവിടെ ECG പ്രോബ് വെക്കുന്നു, അതുവഴി ഒരു എക്സ്ട്രാ കറണ്ട് വന്ന് നമ്മുടെ പേഷ്യന്റ് ഹർട്ട് ആവാൻ പാടില്ല. ഇതൊക്കെ ടേക്ക് കെയർ ആകാൻ വേണ്ടി റെഗുലേറ്ററി പ്രാക്ടീസസ് ഉണ്ട്. ഏത് ഡിവൈസ് നിങ്ങൾ ഡിസൈൻ ചെയ്താലും ഇറ്റ് ഹാസ് ടു അഡിയർ ടു ദീസ് റെഗുലേറ്ററി പ്രാക്ടീസസ്. ഇതിനെക്കുറിച്ച് പഠിച്ച ആൾക്കാർ വളരെ കുറവാണ്. ഇന്ത്യയിൽ തന്നെ there are a lot of requirements for these type of people. So now I know slides എന്ന് പറയുന്നത് ഞാൻ എങ്ങനെയെങ്കിലും ചെയ്തെന്ന് പറയാം. So these are not enough actually. So what I thought is like, shall I take you to a demo room and show some healthcare products live? അപ്പം അത് കാണുമ്പോൾ നിങ്ങൾക്ക് കുറച്ചും കൂടെ ഒരു ഇൻട്രസ്റ്റിംഗ്. ഓക്കെ, സോ ലെറ്റ്സ് ഗോ വിത്ത് മീ. We'll go to the next room. I think you are able to see. Yeah. See, for example, I will show one device.
Sir, not visible.
ഈ equipment കാണുന്നുണ്ടോ?
ഇല്ല സാർ, ആ സ്ക്രീൻ ഇല്ല, സ്ക്രീൻ ഷെയർഡിലാണ് ഇരിക്കുന്നത്.
സ്ക്രീൻ ക്ലോസ് ചെയ്താലോ?
എനിക്കൊന്ന് പാർട്ടിസിപ്പൻസ് സാറിന്റെ സ്ക്രീനിൽ ടച്ച് ചെയ്താൽ കിട്ടും. എനിക്ക് കാണുന്നുണ്ട് ക്ലിയർ ആയിട്ട്.
Okay. So this is actually one device which we have developed for. We were talking about early detection of cancer. Okay. From വായിൽ വരുന്ന oral cancer ഉണ്ട്. Oral cancer നമ്മുടെ സാധാരണ എന്തെങ്കിലുമൊക്കെ പ്രശ്നമായിട്ട് പിന്നീട് അവസാനത്തെ ലാസ്റ്റ് സ്റ്റേജിലാണ് ഡോക്ടർ എടുത്ത് പോകുന്നത്. അപ്പൊ അതെന്തുകൊണ്ട് നമ്മൾ ഏർലി ഡിറ്റക്ഷൻ ചെയ്യാൻ പറ്റുന്നില്ല എന്ന് പറഞ്ഞാൽ അങ്ങനെയുള്ള ഡിവൈസസ് ഇല്ല. ഓക്കെ. അപ്പൊ അതിനുവേണ്ടി നമ്മളൊരു ഡിവൈസ്, ഒരു ഓപ്റ്റിക്കൽ ബേസ്ഡ് ആണ്. ഇതിന്റെ ഒരു പ്രോബ്, നിങ്ങൾക്ക് ഒരു ലൈറ്റ് കാണാൻ പറ്റുമായിരിക്കും. ഈ പ്രോബ് ഞാൻ ഇങ്ങനെ എന്റെ മൗത്തിൽ ഇങ്ങനെ വെച്ചിട്ട് സ്കാൻ ചെയ്ത് നോക്കുകയാണെങ്കിൽ യു ക്യാൻ സീ ഹിയർ ഓൺ ദ സ്ക്രീൻ സം ഗ്രാഫ്സ്. ഐ എം നോട്ട് സേയിങ് വെദർ ഇറ്റ്സ് ഹെൽത്തി ടിഷ്യൂസ് or pre-cancerous or cancerous. ഇതിൽ അപ്പോൾ തന്നെ ഇത് അറിയാൻ പറ്റും. Okay, so this is one of the device like which we have developed. ഇത് ഡെവലപ്പ് ചെയ്യണമെങ്കിൽ you have to know the biological details also. എങ്ങനെയാണ് നമ്മുടെ ടിഷ്യൂ ബിഹേവ് ചെയ്യുന്നത്, ഓരോ ടൈപ്പ് ഓഫ് ലൈറ്റിന്. ഇതിന്റെ ഈ ലൈറ്റിന് ഒരു സെൻസിങ്, ഒരു പ്രത്യേക വേവ് ലെങ്ത് ഉണ്ട്, അത് വെച്ചിട്ടാണ് ചെയ്യുന്നത്. So then you can easily see. So ഇങ്ങനെയുള്ള ഒരു ഇതുണ്ടെങ്കിൽ എപ്പോഴെങ്കിലും നമ്മളുടെ ഒരു ഡെന്റൽ ഡോക്ടറുടെ അടുത്ത് തന്നെ ഇങ്ങനെ ഒരു ഡിവൈസ് ഉണ്ടെങ്കിൽ you just scan it, within 5 minutes you will know how your tissues are, whether it is healthy. അല്ലെങ്കിൽ എന്തെങ്കിലും പ്രശ്നം ഉണ്ടെങ്കിൽ immediately you can go to doctor. Normally dentistന്റെ അടുത്ത് നമ്മൾ സാധാരണ പോകാറുണ്ട്. Or this can be done in primary health center where within a few you can go there and get it done maybe within 6 months, 1 year type of. വേറെ ഒരു ഇതുള്ളത് ഇപ്പോഴേ ഇത് സാധാരണ നമ്മുടെ മൊബൈൽ ഫോൺ ഉണ്ടല്ലോ, മൊബൈൽ ഫോൺ എടുത്ത് അതിന്റെ മൈക്രോസ്കോപ്പ് വഴി നോക്കുകയാണെങ്കിൽ ഇറ്റ് ഈസ് ഫുൾ ഓഫ് ബാക്ടീരിയ. അതുപോലെ ഇപ്പൊ ഡോക്ടേഴ്സ് യൂസ് ചെയ്യുന്ന കോവിഡ് ട്രീറ്റ്മെന്റ് എല്ലായിടത്തും യൂസ് ചെയ്തുകൊണ്ടിരിക്കുകയാണ്. അപ്പൊ അതിലേക്ക് വേണ്ടി നമ്മളൊരു സിമ്പിൾ ഒരു സാധനമാണ് ഡെവലപ്പ് ചെയ്തത്. സോ യു ക്യാൻ സീ യൂസിങ് UV light, you just put all your mobile phone and all inside and just close it and then just press it. അപ്പൊ ഞാൻ ഒന്ന് എടുക്കാം, കാണാൻ വേണ്ടി UV light ആണ്. Okay, so this device is designed in such a way that if you show it to your eyes or face, it will automatically switch off, because UVC light and blue light is very dangerous to injurious to eyes also, and it is not being used. So we have designed with an accelerometer so that if you look at that, it will go it will switch off. So that is how it is done. So you can use all your mobile phone, watch എല്ലാം ഇതിനകത്ത് വെച്ചിട്ട് ജസ്റ്റ് ക്ലോസ് ചെയ്യുക, ഇതൊന്ന് പ്രസ് ചെയ്യുക, ഈ സ്വിച്ച് പ്രസ് ചെയ്യുക, that will get sanitized completely. So this is one thing. I will show a few more. ഇവിടെ വരികയാണെങ്കിൽ just come here. ഇത് സാധാരണ ഈ കുഞ്ഞുങ്ങള് ഇൻഫൻസ് ഉണ്ടല്ലോ, when they are born, നോർമലി നമുക്കറിയാം ഈ മഞ്ഞ കളർ തന്നെ ജോണ്ടിസ് ഒന്നും പറയും, മിക്കവാറും എല്ലാ കുഞ്ഞുങ്ങൾക്കും. അവരെന്ത് ചെയ്യുന്നു പറഞ്ഞാൽ these babies taken into an NICU, they are taken away from mother. ആ NICU-ലെ ഒരു ലൈറ്റ് ഉണ്ട്, അപ്പൊ അതിന്റെ പ്രശ്നം എന്ന് പറഞ്ഞാൽ ഈ ബേബി അവിടെ NICU-ൽ കിടക്കണം, അപ്പം ഫീഡ് ചെയ്യാൻ മാത്രമേ പുറത്തു കൊണ്ടുവരുന്നുള്ളൂ. So what we thought is like, instead of that, can we come up with something like this? What you see, it's a fiber blanket. ഇതിനകത്ത് തന്നെ കുഞ്ഞിനെ കിടത്തിയിട്ട് ഇങ്ങനെ റാപ്പ് ചെയ്യും, ഇത് വെച്ചിട്ട് ടവൽ വെച്ചിട്ട് റാപ്പ് ചെയ്തിട്ട് this baby can be always with the mother. Okay, നമ്മൾ NICU-ൽ ഒന്നും കൊണ്ടുവരുന്ന കാര്യമില്ല. ഇവിടെ ഒരു ചെറിയ ഡിവൈസ് ഉണ്ട്, ഇവിടെ നിന്ന് വരുന്നുണ്ട്. This is widely used now in a big way for this. And one more thing I will just show and then close it. അതേപോലെയാണ് ഇവിടെ ഉള്ളത്. മുമ്പത്തെ റൂമിലേക്ക് വരുന്നത്, ഇവിടെ തന്നെ നോക്കുകയാണെങ്കിൽ ഒരു ടെമ്പറേച്ചർ. So this is given a particular temperature so that the baby is kept in a warm position. So നമ്മൾ പുതിയ ഒരു ടൈമർ ഒരുപാട് കാര്യങ്ങളുണ്ട്. ഈ സെൻസേഴ്സിനൊക്കെയാണ് ടെമ്പറേച്ചർ സെൻസർ. ഇവിടെ തന്നെ if any abnormal comes, then it is given to the nurses station. Camera is always looking at the baby. Okay, upon each screen we can project it to the nurse's screen, nurse's station, as well as the nurse's station also in a room. Relatives in a room projecting on relatives camera next permission permission room. So NIC carry infection. Now we are coming up with an algorithm. For example, diarrhea type of person, the baby will be very much, detect automatically detect artificial intelligence detect immediately inform the nurse station as well as doctors. So, I think I came only for this purpose. So now we will close for any questions.
Sir, we have few questions.
Yeah.
The first question is that how successful can be a BTech in biomedical engineering? Is not better a master's?
Compared to, can you come back again? Yes, I will just settle down.
Okay.
Yeah, please.
Do I need to repeat the question again?
Yeah, please.
How successful can be a BTech in biomedical engineering? Is not better a master's?
Yeah, that is so. I think you are anyway learning the basics. No, see, most of the biomedical engineers earlier, we are all electronics people. So we learned, there was no specific biomedical course, but now it is very much focused on the biomedical thing because we have not learned much on the biological side. Okay, so I think it is very, very good to even to have a BTech in biomedical thing. I think you will be independent enough to go with the profession.
Okay. Second question is, which are the good colleges offering degree in biomedical engineering?
Yeah, I think Saharda is one, then TKM Institute of Technology, then Model Engineering College also there. Only a few colleges are there now, but I think the more will come up very soon.
Okay. The second question is that the same thing as the masters, but the question is that most of the colleges don't have any hospital support. Is it essential for studying the biomedical engineering?
Yeah, I think hospital support is always there. I think they have these most of the researchers as well as the professors are having link up with the hospital also, but it doesn't matter. I think initial days, when you learn the basics and all, this is enough. But normally for your project and all, I think you will be attached to any hospital as the normal course. We go to some industry. Similar way, here it will be connected to an hospital. Because I have seen many interns, even yesterday, I think after seeing my paper, write up in Hindu, a lot of people called me, they're saying like they have already taken internship in Rajagiri and other hospitals. So I think that the college will be arranging that.
Okay. Thank you, sir. That was actually a really awesome session. I believe the demonstration actually helped the participants to feel the role of biomedical engineers in the society. Thank you very much, sir. Thank you.
Thank you. Thank you very much.
Kasim sir, shall we proceed to the next? Kasim sir, shall we proceed to the next person? Cherian sir is available, right? Sir, sir, please. Sir, are you ready?
Yeah, I'm ready. Yes.
Okay, so can I upload your slides? Share your
Yes,
slides.
yes, please go ahead. Yes.
Okay. Yeah, I think it is already shared, right? Okay.
Yes, Pindo.
Yes.
Yeah.
So, can we start?
Yes.
Okay. Okay. So let me introduce. We have with us Mr. Varghese Cherian, who is heading the technology services in UST Global. Mr. Varghese Cherian has completed his BTech from College of Engineering, Trivandrum in 1992. He worked as a project manager in network systems and technologies. He also held the position of project manager and senior manager in Nest, and he also worked in. He is now currently working in UST Global as head technology services. So I think I have taken his profile from LinkedIn. So sorry, sir, if I could not introduce with more details.
Yeah, Pindo, and currently he is the chair of PI at IEEE Kerala Section.
Okay. So, Kasim sir, do you want to add more?
It's okay.
Okay.
Associated with IEEE Kerala Section for many years. A
Okay.
good volunteer of IEEE and well-wisher of all our activities.
Okay. With all
Welcome, Cherian Varghese sir. And actually, he was having some physical difficulties, and but managed for the session. So thank you, sir. Thank you, Varghese sir, and please join.
Okay, Varghese sir, welcome you. Sir, over to you, sir.
Please check your mic, sir.
Yeah, can you hear me? I was muted.
Yes.
Sure.
Yeah. All right. Thank you so much for giving me the opportunity to be part of this session. This is an area that I'm very interested in, and one of the things that I do quite a bit of, which is mentoring. Can we go to the next slide? So if you take a look at computer science and engineering and you look at the courseware, I think you jumped one slide, or there's one more slide. Oops. Okay, I think there was some material here that is missing. Let me go through it without this thing. You can go to the next slide. I'll keep it. Yeah, just keep it here. Thanks. Yeah, so typically, if you take a look at the computer science engineering, you will find that there are courses in mathematics, obviously programming languages, multiple languages. You will find courses in digital electronics, microprocessors, operating systems, compiler design, and today you will find artificial intelligence and machine learning. So these are the broad spectrum of courses that you will see in typically any general computer science and engineering course. And some of these are common between, if you look at it, electronics and communication, applied electronics and instrumentation, as well as IEEE. But then there is a lot of differences as well, right? Computer science, typically you would tend to see a lot more of programming languages or operating system, which is probably not there in the other courses. Obviously, the syllabus has also evolved over a period of time. And when we take a look at the different courses that are being offered across the different institutions across India, you will also see some of the differences that are cropping up primarily in this space. But if you really look at what is the expectation of a graduate engineer who passes out of computer science engineering, you will find that this is probably common across all engineering degrees, right? At the end of the day, though we are learning certain subjects, the expectation is that we have, for instance, the ability to think critically. Now, these are typically evaluated during the exams in terms of applied questions, where we are asked to take a program and then analyze it, execute it, and we will tend to look at a lot of these skills, right? One is critical thinking. The second is analytical skills, which is being able to understand a question given to us before we try and solve it. Obviously, problem-solving skills, the ability to look at a problem, understand what is required to solve it. The logic and reason, which is a fundamental requirement in computer science, because almost all of the programming languages need some level of logic, some level of reasoning to write the code and to solve the problem that we have been given. As part of that, a critical element is troubleshooting. Troubleshooting is being able to understand if your program goes wrong, where it went wrong, how it went wrong. How do you go about trying to understand the point at which it went wrong? And then obviously looking at, analyzing the problem and finding out ways and means to solve it, right? Detail orientation. This is one element that engineers are supposed to be really focused on, right? We don't deal with qualitative aspects. We typically look at a lot of quantitative aspects, which means that our level of attention to detail has to be extremely high. The other element is crafting solutions. Typically, the problems that we get during the college could be a combination of simple problems, complex problems, but being able to understand how to solve it and to create or craft a solution or craft an answer is a very critical element that we learn as part of our graduation. Obviously, time management becomes very critical, whether it is submitting your assignments on time, carrying out your assignments on time, whether it is your exams itself, managing your time during the exam, so on and so forth, right? A very critical element that is also looked at is learnability. And we'll touch upon learnability in detail later, but one of the things that's extremely important is to understand and to realize is modern curriculum only takes you to a certain extent, right? The level at which technology is changing used to be probably once in 20 years and 30 years, if you take a look at the 1970s, to literally overnight in the 2020s. So keeping up to date with that level of change is extremely tough, especially from a curriculum perspective, which means that what we learn in the college is just the base platform that should enable us to learn a lot more, even during the course of the curriculum. So a lot of our effort is also going to be spent in trying to understand and learn new things that are outside the syllabus. Communication, the ability to write, the ability to craft a response, the ability to be understood, the ability to present are all very critical elements that we will go through during the course of the engineering curriculum. Can you go to the next slide? So if we take a look at the different courses that are available across the country, I took a snapshot of different universities and institutions. If you look at Kerala Technical University, our bachelor's degree is BTech in Computer Science and Engineering. Whereas if you take a look at Amrita, and then if you take a look at NIT, IITs, Triple IT, you would tend to see that a lot of these are typically BTech degrees in Computer Science and Engineering. But some of the newer universities, if you take a look at Amrita, if you look at Vellore Institute of Technology, they're starting to offer a lot of very specialized computer science and engineering degrees. So while you get a BTech in computer science and engineering, you get a specialization in AI or cybersecurity or bioinformatics or IoT. And in some of these cases, there are also cross-department degrees that are being given. So for example, cybersecurity systems and networks, embedded systems, wireless networks and applications, electrical and computer science, computer and communication, and so on and so forth. So you're starting to see a lot of customization in the course offerings that are being seen across multiple organizations, in India itself, let alone the ones in foreign universities, which I really haven't touched upon. But if you take a look at IITs, NITs, IIIT, KTU, the difference that is starting to come out is more and more in terms of the electives that you get during the course of the curriculum. A lot of the electives are primarily cutting edge or bleeding edge areas that gives us the opportunity to learn a course in that specific technology or that specific area during the course of the curriculum as well. So these are some of the computer science courses that we see across India. Now, once we graduate, can you go to the next slide, please? Once you graduate, typically what do? Right? One possibility is obviously continue our education, right? And go on to do a master's. So if you take a look at different masters, one of the things that you also see, which I didn't cover in the pure undergraduate computer science course, is the fact that a lot of organizations are starting to provide dual degrees. So you get a BTech plus an MTech in about 5 years, and that is something that is being seen quite a lot, primarily because it gives us the ability to get a base in computer science and also a specialization by the time you pass out, right? So you get a degree in you get a BTech degree in computer science and engineering, and an MTech, which is a specialization. But having said that, even if you take a look at the same set of organizations that I covered in the earlier section, you will find that there is a whole lot of variations that are starting to come up in the computer science and engineering spectrum. So organizations or institutions are going beyond just the pure computer science and engineering or a master's in computer science and engineering into providing very, very, very specialized courses. Cyber is a huge area that you are seeing a whole lot of interest in. Almost every single institution, you will see something around information security, cyber security, information science, data science, data analytics, AI and machine learning, security systems, cyber physical systems, computational engineering. So these are all the different specializations that you're seeing a whole lot of interest in as from a MTech perspective. Obviously, there are a lot of organizations that are providing dual degrees in terms of MTech plus PhD. But again, typically you would tend to go for a PhD, either when you're going in for a consulting kind of a job, or you would want to continue with teaching as a career. So these are some of the, when I was looking through the different institutions, these are some of the opportunities that are there beyond computer science and engineering. But then if you go and look at the job, what would be the different areas that you would tend to see from a job perspective? Can you go to the next slide, please? Right. So if you take a look at what is out there in the industry today, these are some of the typical job opportunities that exist in the industry. Obviously, the one that has the most amount of visibility today is what is the programmer role, right? Primarily, the focus is that you would learn some level of programming languages, and then you will essentially be able to write code or deliver some piece of software to your clients. That's typically what the programmer role is all about. There are a lot of newer roles that have come up in the last decade or so. One is data analyst. Typically, a data analyst would be somebody who's focusing on trying to understand the requirements of the data, trying to look at how to visualize data, trying to look at, so for example, you would see really good-looking dashboards that provide a lot of content. The people who design that could be a combination of a data analyst. The people who decide what data needs to be there is typically the analyst. The data engineer, on the other hand, is the person who will work on all the background systems from which all of this data needs to be collected so that you can actually visualize it and demonstrate and view this on a dashboard, right? So that's the typical data engineering role. The other roles, which are probably a combination of maybe electronics as well as computer science today, that you see quite a lot of, is the embedded or the IoT engineer. Embedded is typically more in terms of the hardware. The IoT engineers could be a combination of hardware, firmware, as well as the application side programming languages also. But this is again an upcoming area. There is a lot of interest, especially with the advent of Industry 4.0, which is completely changing the way manufacturing is done or supply chain is being carried out in the industry. This is becoming more and more a very relevant job and a more in-demand job to kind of talk about. The other is VLSI. VLSI engineers typically tend to come from electronics and communication or IEEE or AE&I, but you will also tend to see computer science engineers there. Here, the focus is more around designing chips, designing what is called as ASICs, which is application-specific integrated circuits, and so on and so forth. But this is, again, a very specialized skill. There aren't a whole lot of people there. You would tend to see them in organizations like Intel or Texas Instruments or Next, and so on and so forth. Embedded programming, data analyst, data engineer, embedded, you would tend to see them in most of the service industries, but VLSI is probably a lot more specific to the semicon industries to a larger extent. Qualcomm, Intel, Micron, and so on and so forth. AI and ML is another area that is coming up extremely fast. Typically, you don't tend to see a lot of computer science graduate engineers here. You tend to go with people who are a lot more postgraduate or have a postgraduate degree. But this is an area that is speeding up so fast that it's extremely tough to keep up with it. But this is fundamentally, dealing with artificial intelligence and machine learning and different aspects of it. You would also tend to see data analysts or data scientists that would also need to have some level of AI and ML skills, as would sometimes programmers as well. The other area that I can think of, especially in the pure computer science area, is something called the infrastructure engineer, where the job description is typically about managing the computer infrastructure, whether it is networks, whether it's communication, whether it is storage, whether it's servers, and so on. That is another area that you tend to see job opportunities in. Now, if you take a look at non-engineering jobs, when I say non-engineering, I would say non-pure engineering jobs. Some of the others that you tend to see in the industry, one is around business analysis. Typically, the need is for people to understand business, because as the term suggests, this is all about being able to understand the domain that you're supposed to work in, whether it's healthcare, whether it's hospitals, whether it's retail, whether it's manufacturing, being able to understand that area and to create and to have what is called as domain skills or domain knowledge. That is where typically you would tend to see a lot of the business analysts or analysts coming from. Banking obviously is a big area. I think a couple of years back, there was a huge movement, especially during the last recession. There's a huge movement in people moving from the IT industry towards banking, because there was a lot of opportunities in banks, from SBI to all the public sector banks, as well as some of the others as well. Obviously, you would tend to have your pure, your core engineering job roles, which I've kind of I haven't really put that here, but then, as a civil engineer, you would certainly have jobs in the civil industry. As a mechanical engineer, you would tend to have jobs in the mechanical industry. As an electrical engineer, you would have all of those. Some of them are also going more and more going to be cross-cutting, in the sense that most of these core engineers also tend to see a lot of computer science requirements. So you would also tend to see computer engineers playing these dual roles as well, depending upon some of the opportunities that are there. The other is obviously management, especially, you tended to see a lot of this with public sector organizations or steel industries and so on. when you would typically, they want to hire graduate engineers, both typically in the core areas, mechanical, electrical, computer science, electronics, and so on, to start looking at taking off in the management side of the world, typically dealing with supervision and other management areas within large organizations. And obviously the last one, but not the least, is consulting. Again, this is very less in the graduate space, a lot more in the postgraduate and the PhD space, or the doctoral space. These are typically organizations like the McKinseys of the world, the Gartners, the Forresters. These are typically consulting organizations that tend to hire consultants. They could be a combination of domain skills or computer science skills that are required, but you would also tend to see that and then if you're also graduating from the top tier institutions, let's say the IITs or the NITs, some of these institutes do hire consultants directly from there as well. So this is more like the potential job opportunities that the typical computer science engineer will see in the industry today. And again, these roles are changing quite rapidly. So by the time you join and then you graduate, some of these roles might even be redundant, and you would probably see a lot of newer roles coming up as well. Now, can you go to the last slide? So if you take a look at what we discussed so far, the focus of an engineering degree at the end of the day is a combination of hard and soft skills. The hard skills being the technical skills, the soft skills being all the softer skills that you would learn during the course of your career, of your degree, which is presentation, communication, the art of writing, the art of speaking, and so on and so forth. Like I mentioned, today there is certainly a need to study beyond the curriculum. We don't have a choice. That is extremely important to especially get job opportunities. The other area that is a big challenge that we see in the industry is college tends to really focus on individual aspects, right? You write the exams by yourself. People do write it jointly, but ultimately the focus is that you're responsible for writing your answers yourself. But typically organizations tend to focus on teams, which is why it's also important for most of the engineers getting into college or studying in college to also look at gaining experience in opportunities that deal with working in teams. The other is, if you take a look at what is around us and what is happening, there are opportunities. Because today, if you look at it, computer science or computers and technology has touched every industry. I mean, there is a general saying that every industry is a technology industry today, which is very true. So the opportunity for a computer science graduate to really get a job is extremely high. But two things, right? You need to really focus on your curriculum. You need to make sure that you study your subjects really well, graduate as far as possible at the top, or at least be able to know your engineering subjects extremely well, because that's the only way that you can create a unique brand for yourself that enables you to get in and get an opportunity. The other thing is, in the pre-COVID days, I would have said this very confidently, but in the post-COVID days, we are seeing a sort of a recessionary trend. Now, during the course of a recessionary trend, at least what I have seen in the past is the jobs in the technology space tend to go down quite a bit across industries. The service industry is also struggling to a large extent today because the core industries are not doing very well. Now, in such a space or such an environment, it is always a better idea to probably think about continuing your education and going on to take a specialized degree, because then you become highly skilled, and if it's in an area that is in demand, obviously the opportunities again abound. So that is in summary what I would like to talk about with respect to computer science and engineering, the course, the different courses that are there, what you will learn, and if you want to continue, what would be post your studies, what are some of the opportunities that are there, both in terms of education as well as in terms of the job. With that, I pause, and I'm open for any questions that are there.
Thank you, Cherian sir. And I think there is no question. Dr. Findo? Any questions? Yeah, chat box. I am not seeing any new questions. So, thank you, sir. Thank you very much for the highly informative presentation. And yeah.
Thank you. Thank you very much. And thank you for giving me the opportunity, sir.
True. Okay. Dr. Findo? Dr. Findo? Dr. Findo is there? Madhu is there?
Yes, sir, I am here.
Okay, next is my presentation.
Yes, sir. Sir, can you see my screen?
Yes,
Kasim, sir?
Yes, I can. Yes. Dr. Findo is there? So, Dr. Findo? Okay. And
Yeah.
Dr. Findo?
Okay, sir, I was muted. That's why I cannot talk.
Yeah, please,
Okay.
please introduce then.
Madhu, can you unmute Kumaravel, sir? He will be introducing Kasim, sir. Kumaravel.
Okay, sir.
Kumaravelu, sir.
Yeah, thank you very much, sir, for helping me to unmute my mic. Hello. So very good evening to all of you. This is a great opportunity for all the participants to decide the career of their wards. I am very happy to give introduction about Professor Kasim, sir. So Professor Muhammad Kasim is graduated in electrical engineering from TKM College of Engineering. Post-graduated from College of Engineering Trivandrum, joined TKM College of Engineering as a faculty member in January 1981. So from there, he retired as professor from TKM College of Engineering in 2011. In between, Sir worked at Saudi Arabia for 5 years in design of substation projects. He joined in IEEE in the year 1986. And an ex-IGAM member of IEEE Kerala Section from 2010 onwards. So, Sir has bagged a lot of awards, especially from IEEE Kerala Section, IEEE IEEE Chapter. By mentioning, he received Arten Best Student Brand Counselor Award in the year 1989, the PES Outstanding Chapter Award 2012, 2013, Kerala Section Outstanding Volunteer Award 2018, IAS Chapter Website Award in 2019, etc. So with this brief introduction, I invite our Professor Kasim sir to speak few words.
Thank you, Dr. Kumar Velu. Thank you all the team behind this webinar, and I thank all the participants for joining this webinar. And my role is to introduce electrical and electronics engineering. And for this electrical and electronics engineering, myself and engineer CM Varghese is the CEO of Evergreen Energy Technologies Kochi. We will be sharing and I will be concentrating on the academic part, and Varghese sir will be concentrating on the industry aspects. And I will just highlight the schemes of our electrical and electronics engineering of Kerala Technological University. And currently, the 2019 scheme is running, and 2014 scheme was there up to 19, and 19 they started the new scheme, and so only up to S3, S4 all subjects are there in the website. So I took 2014 scheme as well as 2019 scheme to introduce the subjects of electrical and electronics engineering. Madhu, next slides. Yeah, and this webinar is jointly organized by Educational Activities and Strategic Initiatives for Academic Engagement. Now next. And you can see that the scheme for AAA and the first 2 semesters, we are having engineering maths, engineering physics, chemistry, engineering graphics, C program, basics of electrical and electronics engineering, basics of civil and mechanical engineering, life skills and professional communication. These are the main subjects covered in first year. And this is common to most of or in most of the branches, in these subjects. In addition to this, there will be a core subject relevant to the respective branch, and for AAA, it will be the introduction to electrical engineering, the core subject. So these are the subject, and you can see that the maths is included, and a basic of engineering physics is there, chemistry is there. Then we have to learn graphics, C programming is also included, and so these are the subjects that is covered in the first year. And then in S3, S4, next slide. S3, you can see that maths is there, then circuits and network, measurements and instrumentation, analog electronics, electrical machines, and humanities. So the core subject, it comes as electrical machines, analog electronics, circuits and networks, and measurements and instrumentation. The maths is also there. And so the machines, electrical machines, basically the DC machines and transformers are covered in the S3 syllabus. And you can see that for the S4, it is a probability distribution, that is a mass, then synchronous and induction machines, then digital electronics and logic design, material science, measurements and instrumentation, and labs are also there. So these subjects covers in S3, and that is a second year. And next slide, please. For S5 and S6, the power generation, transmission and protection is there, linear control systems, power electronics, signals and systems, microprocessor and embedded systems, and one elective is also there. And for the S6, it is electromagnetics, advanced control theory, power system analysis, electric drive, principles of management, and another elective. And this is actually referred to the 2014 scheme. And for the 2019 scheme, there will be small changes with respect to these subjects. Next slides. And for S7 and S8, S7 we can see that it is electronic communication, then distributed generation and smart grids, electrical system design, digital signal processing, electrical machine design, then the elective 3 and seminar and project preliminary, and there is another lab, power system lab. And for essay, only theory subjects and project is there. That is a special electrical machines, industrial instrumentation and automation, elective 4 and elective 5, 2 electives. So these are basically the subjects that a student has to study during his course in electrical and electronics engineering. And we know that most of this electrical engineering machines, as we know that current is not visible. The working of machines and so on, it is to be having with an imaginary vision. So we have to imagine how flux is moving and how current is going from one place to another place, like that. That imagination is to be there. And while studying this course, it is very important that we have to learn the subjects very thoroughly. And only the job opportunities comes to you only if you know electrical engineering in a good fashion, in a good manner. That is very important. Now, after graduation, without electricity, as you know, there is nothing without electricity. In our days, we can manage without electricity. And in my days, my house was my native place. I am from Kottaragira, and my house got electrified only in 1983. I passed out engineering in 1978. So at that time, we were able to manage without electricity, but now it is not difficult to manage without electricity for say few hours. So that is the significance of electricity. All the field covers and the use of electricity is very, very, very high. The demand is also like that. So the knowledge of electrical engineering, the content of the stuff that you learn from electrical engineering, electrical and electronics engineering is very, very important. And recently I made an interview for a private college, that is a faculty selection, and I gave a test for the these candidates. And out of 16, only 6 persons with MTech qualification scored 50% and above. That means that the quality of the students or the graduates has to be high, that is to be competent for get jobs. And the job opportunity is very, very high in all over the world. Not in Kerala, not in India. The electrical engineers, the job opportunity is very high. But the thing is, when you write a test or when you go for an interview, you have to present your written test has to score maximum marks. Then second, you have to perform very good in interview. Then the chance of getting a job is very, very high. And you can choose your choice. You can have your own choice where to join, like that. Okay, next slides, please. Madhu, yeah. Opportunities for electrical engineers. You can see that electrical engineers can find a number of employment opportunities in various different sectors. Some of the top sectors that hire electrical engineers are given below, and they are on engineering services. So that means we have to qualify for engineering service exams to get placement in engineering services in India. Then in the field of electrical power generating installations, generating stations, and like that. Okay, so there electrical engineers are mostly needed for power generating stations, whether it is hydro or diesel or thermal or atomic. So all these places we need electrical engineers. Then Indian Railways, there is a need of electrical engineers. Then aerospace manufacturing industry, then automobile industry. Now we know that most of the vehicles are going for electric vehicles are coming up. So there are also very high need of electrical engineers. Then government electrical works departments like PWD and CPWD, then navigational equipment manufacturing industries, architecture and construction firms. That is actually in design engineers, we need electrical engineers to be working with civil, structural, architectural and mechanical engineers together. Then we need in substations, high-rise buildings, etc. So there are the number of opportunities for electrical engineers in the, as I said, architecture and construction firms. Then you know that this state electricity board is there where the electrical transmission and distribution, so generation, transmission and distribution, electricity board requires engineers for all these areas, and starting from assistant engineer to chief engineer, then the director or direct board member of electricity board. So many positions are there in electricity board also. Then comes electrical inspector. Then another interesting field is the teaching. So if you have a passion, after graduation you can go for post graduation, and rightly now the current minimum qualification is post graduation in engineering for a faculty position as assistant professor, and the current salary is something like 60,000 rupees per month for a fresh faculty, okay, in government and like colleges. So next slide, please. Madhu. Madhu, please. So top recruiting companies for electric engineers. Yeah, top recruiting for electrical engineers. Some of the leading companies where electrical engineers can look for relevant job opportunities are given below. One is the Reliance Power Industries, very large industries in India and as well as outside also. So Siemens Technology Services, then ABB is there, then RITES is there, International Business Machines Corporation, that is IBM, Google, Apple, General Electric, BMW Group, Lockheed Martin Corporation, then Boeing Company, Shell Oil Company. Then in teaching field, as we know, in IITs, then Indian Institute of Science, then NITs, then engineering colleges, all there. So many need for electrical engineers as faculties in the electrical department. Then as we know, we have lot of positions in Kerala State Electricity Board and other electricity board within India, and then electrical inspector. So these are some of the top vacant companies or positions we can have for job inquiries or job positions. Next. Yeah, and the pay scale and salary of electrical engineers, as we can have a minimum of, starting with a minimum of 3,50,000 per annum. That means approximately 30,000. That is IT industries also give. We can have a job opportunities in IT companies also, because if you are well good in programming, you can have the chance of getting job in IT companies also. Starting package is that is a minimum is 3,50,000, so approximately 30,000 per month. And so then again in IT companies, the minimum package depends on your capabilities or your capacities. Some people, they do get 2 lakhs per month also. That is their ability or their capacity to go work for the company, that company. And for a medium level, middle level, the salary per annum is 7 lakhs. So it comes to 50 to 60,000 per month. And for a senior level person, the salary goes to 15 lakh, that is 1.25 lakhs per annum. This is an average. And if you are working with, say, very big companies or IT companies, your salary can be double of this or even more than that. So a very good package is there, provided you have to prove that you are a good engineer. You are a good electrical engineer capable of doing things that is assigned to you. Okay, next slide, please. Yeah, the pros and cons of becoming an electrical engineer. Electrical engineers, the pros are the electrical engineers are offered with some of the topmost salary packages as the job is highly skill based. Then second is the electrical engineers can choose to work in a variety of industries, including telecommunications, computer, aerospace, etc. Then with the right skill set and adequate professional experience, that is a most important point. Electrical engineering can escalate to management positions. Then there is a lot of job flexibility as one can easily shift to sub-disciplines. Then the cons are the job of the electrical engineers can be very stressful, especially when the equipment or the design has the potential to impact human life. And another is it is a risk occupation due to the nature of job. That is, if you are directly dealing with electricity, electrical engineers at times may suffer personal injury. Not all electrical engineers, only with those who are dealing with electricity. Due to the advancement of technology, electrical engineers have to constantly update their knowledge. Electrical engineers have to update their license in specific fields from time to time. That is regarding this one. So there are so many pros and cons when you become an electrical engineer, and that actually depends on the field in which you are working. Okay, next slide, please. The challenges of electrical engineers in the coming century or in the 21st century. This I have taken from IEEE Explore, and it says the future is indelectric, that is intelligent electricity, electric energy that is secure, clean and efficient. This is a major challenge of electric engineering in different fields. The role of engineers is to integrate science, technology and the business world, and hence to make things happen. Engineering is about finding ways to modify the universe and life in order to extend our biological reach, the quality of our lives and the niches in which we can survive. Technology is the means of improving human life by the application of all knowledge and experience. Innovation is the successful introduction of something new. It is not enough to pursue the vice of nature or to find how we can modify nature. We must also decide what we should do. If engineering is to have a strong say about the future, it needs to become integrated with science, society and humanistic concerns. 21st century engineers will need to be astute makers, trusted innovators, agents of change, master integrators, enterprise enablers, technology stewards and knowledge handlers. Engineering should venture to develop new capabilities and a broader sense of mission. We should integrate what we know, what we can do and what we should do. We should also to be able to integrate the biological organism, society and machines. We should strive to engineer a better tomorrow guided by a desire to give future generations a greener, healthier and more harmonious world. So this is the challenges that electrical engineers has to face in this 21st century. So basically in engineering education, if you choose electrical engineering, you have to be a good student learning engineering in a good understanding method. That is, when you go for a test, that is after your graduation or post-graduation, depending on the choice of your job, then normally all of you have to face a written test and an interview. And written test, you have to score good marks, then only you will come in the main list. And similarly, interview, you have to perform in a good manner, and you can perform in a good fashion only if you know the subject very well. So study well, very well the subject. The job opportunities are enormous, and you can be a very good electrical engineer working in either in teaching or industry or in the design field. And design and estimation is there. Then design of projects like substations, then transmission lines, then power stations, etc. It is there. Then there is testing and commissioning of substations, generating stations, etc. Then in industries, that is the manufacturing industries, quality control is there. Then testing of equipments as per standards is also there. So the scope of electrical engineers is enormous, and for that you have to be a very good and quality electrical engineer. Thank you very much. Madhu, next slide. Any questions, any queries? Yeah, okay, thank you all. And now Mr. CM Varghese, Engineer CM Varghese. He is the chair of Evergreen Energy Technologies. He will present the remaining industry part, and I request Kumar Velu to invite. Thank you all.
Thank you very much, sir, for your valuable suggestions about IEEE, electrical engineering stream. So we are really proud to be an electrical engineer because without electricity, we can't run our life. So it is recommended as fourth basic need of human. So in continuation to the lecture given by Professor Kasim sir, I invite our CM Varghese sir, who is currently Vice Chair of Educational Activities, IEEE Kerala Section. So he has completed his BTech in electrical engineering from REC Calicut in 1978, now currently known as NIT Calicut. He completed his MBA from College of Engineering Trivandrum in the year 1989. So he is a senior member of IEEE since 1995. He was the chair of SEAM Kerala for the year 2017 to 19. So currently he is a vice chair of IEEE Educational Society. She worked in Keltron from the year 79 to 96. Trainee engineer, finally become manager in engineering. So he was having wide experience in the as a LV design manager with Schindler Electrical from 1996 to 2001. Since 2001, he is with IGA Technology Industrial Electronics Private Limited and was the managing director of the company till March 2019. Since May 2019, CEO Evergreen Energy Technologies Private Limited Cochin, a solar EPC cum consultancy company, empaneled with NSDC, Government of India for various solar power system trainings. Also undertaken R&D projects in power electronics products, UPS, inverters, power supplies, etc. So with these brief words, I invite engineer CM Varghese sir to continue lecture given by our Kasim sir. Welcome, sir.
So thank you, Kumarvel sir. So my job is very easy because Kasim sir has already covered most of the areas in electrical engineering, and I will just touch upon some of the areas with reference to industry. Now, to give an understanding for the aspiring students about electrical engineering, so just look at around in your own home and see the electrical equipments and devices there. Just see in the room where you're sitting, you can see your lights, your fans. In your kitchen, you can see so many appliances working daily. All these things are handiworks of electrical engineers. And if you go to the factory, any type of factory, you can see a lot of motors. We used to say motors are the horsepower, the working horsepower of industry. Like, there are so many machines, equipments, heating, lighting, cooling, ventilations, so many things pumping in any industry, which are all monitored, controlled by electricity and so electrical engineers. So electrical engineers are everywhere, every factory, every sphere of life, right from your your panchayats to your society, any areas of the society to any industry, to tractions, railways, everywhere it is there. Now, the fundamental thing what we have to understand is, electrical energy is a secondary energy, where the primary energy we know it comes from fossil fuel, that is the coal, the petroleum, gas, all these things. And if you look back some 150 years to present day, this 150 years, the development of the humanity to the present level has come up to this stage mainly by utilizing these energy resources. And the overconsumption of these resources as of now, we know we are at the verge of a very, very damaging situation of global warming, and so climate change and pandemic like COVID. So at the same time, we need energy, we need growth, we need GDP. So electrical energy is being secondary energy, which is we convert from the primary energy either from coal or gas or potential energy like water in the dam. And if you look at different countries, one thing you can note, the prosperous country, the rich countries are always using more energy. That means energy is considered as a yardstick of development. For example, an American will be using almost 10 times per capita energy that of an Indian. You know, America is a developed country, where we are only a developing country. So as we develop more and more, we need more and more energy. But at the same time, when we consume more and more energy, it will emit out more CO2, making the global temperature more. Again, unless otherwise it is not arrested, it will create pandemic like what we see as of now. But there are ways to arrest it. That is what is the renewable energy. And that is one of the main area which we have to look into as far as a electrical engineer, how we have to move from fossil fuel energy to renewable energy. So coming to an electrical engineer's learning areas, see, you start from power generation, transmission, distribution, storage, measurement, control application. These are the basic areas an electrical engineer has to cover. And during his career, either one of these areas, if he's working as an electrical engineer, he has to concentrate at least. And coming to the application, you can see, if as far as when I'm talking about in industry, see the motors, which are the workhorse of an industry. We coming to the transportation, the traction. Now the next area, we know the IC engines are getting changed to electric vehicles. The next 10 years, you will see more or less the IC engine vehicle, the diesel cars, petrol cars will be out, and it's all going to be electric vehicles. And lighting, you know, it was from fluorescent lighting, we already moved to LED lighting. So that is the energy efficiency. Then heating, cooling, refrigeration, either at home or at your factories or offices, there is another area. Then all your appliances at your home or offices are all working from electricity. And so the application is endless. As far as electrical engineer is concerned, electrical engineering applications are endless. So the roles as already Kasim sir has explained. So it is, if you go to an industry, these are the areas you have to generally work, right from the design development to manufacturing, in charge of a manufacturing or in charge of automation or in charge of a production or in charge of a maintenance or in charge of operation and control. This is the areas where you have to learn, you have to build, and you have to climb the ladder in your career in an industry. And as already sir has explained to you, for higher studies, even not only in our higher studies, even in industry, you need to have a qualification in these areas, because the technology has advanced so much. Because unless otherwise we don't cope up with what are the latest, we will not be able to climb up your career. So the opportunities also, like, you know, not only the discoms, that is the electricity boards, you have power generation companies. In India, you know, we have NTPC, we have BHEL, we have so many other power generating stations by state-wise. You have power grid. It's like many companies are here. Then lighting industries are many are there. Now the traction also, you know, you see all the trains are now electrified, you know. So electricity is widely used, and even it is an electric engine or electric motors are there on the traction. So all these things are getting electrified, means electricity use is getting widespread. And again, coming to R&D side, you can see even in Kerala, you can see a lot of R&Ds like VSSC, DRDO, the CDAC, a lot of R&Ds are there, and it's all more and more coming. These all areas, electrical engineers can get opportunities and they can climb up in their career. And on the employment side, this is what we all want to know, because after getting graduated in electrical engineering, what is your opportunity? Okay, see, the opportunities more than what we have described. We all, rather than looking at being an employee, as far as Kerala is concerned, it is already time to look to be an entrepreneur. See, if you look at industries across India, SMEs, that is the small medium entrepreneurs, are the backbone of Indian industry, which is having more than 50%, or not 50%, almost 2/3 of the employment come from these industries, and many of these industries are run by engineers. If you ask a Gujarati student, what is your plan after education, he will tell the industry where he is going to start. Whereas as of now, for a Keralite, even the parents discourage students to be an entrepreneur. So we have to change that mindset up. We have to come out, and while studying in the engineering itself, you have to understand one more thing. Within next few years, you will be selected from after your pass out by your skilling, not by degree or degree mark. So while you be an engineering student, unless otherwise you skill for some particular jobs, you will not be required by any industry. Unlike in the past, industries will not have resources, or they will not spend resources to skill and train the graduates. They don't want raw graduates, they want skilled graduates. So please be reminded, in your 4 years of study in engineering colleges, you have to skill some particular jobs to get employed after that. So one of the major areas is the SMEs, where a lot of opportunities are there. Maybe you have to start as a single man industry, you have to grow up. Any industries are like that. Okay, it's just like being an entrepreneur is not a simple thing. Just like a young girl become a mother, conceiving a child and bringing out the child up, and the child is becoming self-standing. And entrepreneur also has to do the same way, but end result is great. You will have the satisfaction of getting self-employed, giving employment for so many, and building infrastructure to the nation, bringing prosperity to the nation. If you look at any country, the prosperous countries are where the technology is up. So many technocrats, scientists are there contributing to the building of the nation. So we have to be, being an engineer, you have to be like that. Not getting employed is not enough. You have to be an employer also. If you look at the Americans, almost 55% of the population are engineers and scientists, whereas in India, that percentage is much less. It has to come up. And as of now, we are generating almost 1.5 million engineers enrolled every year. The pass out is less, the standard is less, which you have to improve upon to be in level or in par with the developed countries. Now, in fact, I want to talk a little more about the electricity trends. See, as of now, electricity we get it from fossil fuel. We cannot continue with the fossil fuel, because unless otherwise by 2050, if we do not come out of fossil fuel totally, we do not stop the CO2 emission, our life will be, our future generation will be out of existence. So simple. So that is why world across, the government are pushing policies to build renewable energy, and the purpose is carbon-free grid and fossil fuel-free transportation. So that is why the key technologies for the future is 3 things. One is more electrification in the heating and transportation, and another one is distributed energy. It is no more going to be a central grid as of now what we are going to have. It is going to be a distributed energy system, then the digitalization. So these 3 things I will tell you now. So for the electrification, see, many areas as of now, the energy is not from electricity. As we are going to have more and more renewable energy, this will get converted to electricity. For example, if you look at the cold countries, the heating is not from the electricity as of now, but this will go to from electricity. And if you look at the automobile sector, it is from the petroleum, which will eventually change it to electricity. So these are the 2 key areas. Another area is, as we are going more and more renewable energy, especially the solar energy, the solar energy is intermittent. It's not available 24 hours. but we need energy 24 hours. The storage is going to be a main criteria. If you look at the electrical engineering side, the major R&D is happening across the world. The technology, the many large companies are spending billions and billions of dollars for the research in the energy storage, coming out with a better battery with a high energy density, especially for the electric vehicle with a more range, more mileage. So in the future, you can see your car will be electric vehicle. In next 10 years, definitely your car will be electric vehicle. And next 10 years, your car will be autonomous vehicle, that is a driverless cars. And these cars, while at your home, carry almost 30 to 75 units of energy. So you need not have energy from outside. So this energy the batteries in the car you charge through your rooftop solar systems. So you generate electricity at your home. So you are going to be a prosumer. Prosumer is the one who produce and consume energy. If excess, you can sell also. So rather than going to have electricity from the Talcher or the Ramagundam, you will be generating your own electricity. If excess, you will be selling outside. So your car will be carrying your energy. So this is what is going to have. So we say it is a vehicle to grid and grid to vehicle or grid to home. These systems are going to come so soon. It is already there in some kind of countries like Australia. This is already there. So another area of electrical engineer where there is going to be lots and lots of potential in the career is energy efficiency. It is being told in US alone, next 10 years, $2.4 trillion of energy efficiency business. Increase the efficiency. For example, you remember our lights were fluorescent lamp, and by changing it to LED, we have doubled the efficiency, isn't it? So that is energy efficiency. So when you change from poor efficient devices to a higher efficient device, like your 3-star AC to a 5-star AC, or old fridge which was consuming a lot of energy, you change it to a better one, star one. Like that, a lot of things. When you go to an industry, you can see the efficiency of some of the equipments are so poor. So poor, especially for the compressor side, or it is being told it's only 8 to 10% of the efficiency. For IC engine, what is the efficiency? The tank to wheel efficiency of a petrol or diesel engine is just 20 to 22% only. Whereas my electric car, it is 75%. So there is a difference. So energy efficiency is one of the biggest area for engineers, especially electrical engineers, to play with in the coming years. And renewable energy is the another area where we have to see the next few years, many of the thermal power plants, coal plants will be shut down. And these are to be replaced with renewable energy, but large solar farms or rooftop solar farms. And your home, your village are going to be microgrids. Few homes together or a single home as such, we can say a microgrid. So this is what is going to happen. This is the areas where individual entrepreneurship is there, individual job opportunities are there. You are generating electricity and consuming there itself rather than transporting and losing by losses. So the digitalization side, you can see there is a real-time automated communication operation of the system. As of now, the meter reader come to every 2 months to our home and take the readings. But in future, not future means it is available now. He will read this energy meter from his office. He need not come here. So that's a smart meter. All these facilities will be there. So you have a smart meter, you have smart sensors. So when you have an automated car, there are hundreds of sensors in the car. It senses everything in front, in and around, back, side. So all these are the smart sensors. And you have remote operation and IoT for the appliances at your home. You'll be able to control your appliances from your office. Appliances in your home, you'll be able to control from your home. Like that, a lot of things will happen in this field. That is the effect of digitalization. Now, to conclude, see, as of now, the Mother Earth is harmed so much. it is so much warmed up, where large blocks of ice melted down, leaving the virus out, bringing out this type of pandemics, and it will happen again. So it is our duty to reverse that effect, go for green energy. So the green engineering is the design, commercialization, and use of process and products in a way that reduces pollution, promotes sustainability, and minimizes risk to human health and environment without sacrificing economic viability and efficiency. That is important, without sacrificing economic viability and efficiency. The most important thing is our energy, moving from fossil fuel to renewable energy. And that's all. Thank you. Any questions, please?
Thank you very much, sir, for your presentation. Participants, you can post your question in your chat box.
Yes, thank you, Varghese sir. And I think there is no questions on the chat box. Okay, and all the participants are requested to join tomorrow at 4:20 p.m. Right, Findo? Dr. Findo or Kumarvelu sir? Please.
Yes, sir. I'm here. Yeah.
Giving thanks to all.
Yes, sir. Yeah. So thank you all of you for joining with this today presentation. With this, we are winding up the session today. Thank you all of you.
Thank you. Thank you. Thank you all for joining today's webinar. Thank you, Sharada ma'am. Thank you all, Dr. Suresh Nair sir. Thank you, Varghese Cherian sir. Then Cherian sir. Then all the participants and the team, the team behind the screen, the organizing team. Okay. Thank you all. Thank you very much. So let us meet again tomorrow at 4:20 p.m. Thank you all.